Okay, so time for another little video. So on forums and groups and things of 18650s, there's a lot of questions of what's the best capacity tester, can you make your own, why one keeps blowing up, all sorts of things. Well, because I'm an electronics kind of guy, I like to build things as well. I built my own because it's what I do essentially. It's easy for me to do. I can adjust it for my needs, and I can do a whole lot more batteries than just 4 at a time. So that's the route I went down. So to do it, I based it around using an Arduino because they're mega easy to use. They come with boards like this. This is the Mega, all ready to go. So it's a no-brainer. They're so cheap as well. So we've got some power resistors, 10 watt 4 ohm power resistors to act as the dummy loads. We've got some other little resistors over here, some LEDs. We've got some MOSFETs. Now these are logic level MOSFETs, which is quite important because we're going to be driving them directly from the Arduino, so they need to fully switch on at the 5 volts. We've got cell holders. I've got a bunch more here as well. For the purpose of the video, I'm going to do a 4-way tester, capacity tester, because it just makes the wiring simple, and you don't want to watch me solder 16 ways, which is essentially what I'm going to do with this once I'm all done. So the Mega has 16 analog inputs. You can get external analog converters, which are going to be more accurate than what the Atmel chip has in accuracy terms, but I say, you know, 5% tolerance, I'm kind of happy with that, which is kind of what I'm expecting this will be when it's all done. There's some things that we can do to tune it up a little bit to make sure we're not losing too much, but if you're testing on the same tester all your cells, then it's much of a muchness, because you're going to be putting them into your power wall, well, maybe an electric bike if you use enough of them, whatever project you're using. But if you're on the same tester, then you're comparing apples to apples, so you're not going to go too far wrong. So without further ado, I have bent up the legs on these again, as always. That's the negative side as it's pointed. I've bent the positive side up a little bit more, so that I can then solder one of these power resistors in. I've bent the... Oh, I'm useless at this camera work. You can't see that, can you? So I've bent that in a funny kind of shape, like so. So that is now going to solder on to there, like so. Now, my project board for this is a nice shiny sheet of copper, which is actually a circuit board copper. So it is what they call it, fiberglass on one side and copper on the other. I've got a shed load of these sheets, and I've hung on to them for so long. I'm only just starting to use them for things. Downside is that obviously it's all conductive. So over here we have some gaffer tape. No project will be complete without gaffer tape, so I've marked a few points on here that I need to cover. So I'm going to quickly run over and start covering that, so they don't short out. And that's the last thing I want to happen. So I've got to cover it enough for those power resistors, and then the MOSFET. Another lane. Fold those over just to make sure we don't short anything. Right, time to grab a soldering iron. So let's turn that board around, line these up. I'm going to fit 3 more cell holders down there, so I can do the 16 at a time, as I say. So this is rather boring part of it, is soldering, but it's got to be done. I will put up a circuit drawing into the video so you can see what's actually happening. A little bit easier. I've also put the component lists on there for you guys. Not sure where I'm going to put the code, but it is very simple code as well, so it's no biggie. Again, I'm using a large tip on my soldering iron because obviously that's a big sheet of copper, so it'll cool the tip down if I don't use a big enough tip. So got to bend up a few more of these. So these are wire round power resistors, as I said earlier, 4 ohms. So roughly off the top of my head, it's going to be around the 800 milliamp hour load. There are different ways to do this. You could do a constant current load, which I'll probably show you in another video, but this is a very basic tester, just to get you going, and maybe get you into the world of making electronic stuff. It is nice, and if you're DIYing power walls and things, then you're going to have to learn a certain amount of it anyway, I guess. So I do 4 of these, as I said, and just show you guys how it's done. And then if you wanted to do the 16 way, hell, you can crack on and do it. It's just a case of copying. So essentially, once you've done one cell block, it's then a case of copying them to the rest of the cell blocks. But we'll go for it. I've already built one of these before as well, that I should say. I didn't bother putting a screen on it, so I've always connected it to a PC, which is kind of nice because sorry, coughing there, I had an awful cold. But yeah, connected it to the PC, RS232 via USB connection, and that gives you a log essentially of the discharge curves of the cell, which is pretty cool to have, really. I suppose, write it of PC software to plot it in a nice graph or something. At the moment it just comes through a terminal window. There's a ASCII string. I think I might need a bit more tape on here, but we'll see. Get in there. Right, there you go. Yeah, so did I cover the... I had an awful cold and I can't remember what the hell I'm talking about. So power resistors, I also checked their ohmage, and they're all a bit off their marks. So I've written the resistance of them on the sides, so I'll factor that into the software, the firmware for the Arduino, when I'm programming that up, and that will make it a bit more tighter on the tolerances for testing. Right, now the MOSFET, I've got to look up the data sheet for that because I don't know what pinout is off the top of my head. It's probably the same as last time, but it's a different MOSFET, so I best double check. So the MOSFET I am using is it's an ST part, and it's a P36NF06L. It's not bad without glasses. Right. So there's the data sheet. Right, so what I need to do now is call up the data sheet for said device and get the pin out for it, which is right 1, 2, 3. These are different as well. Right, so we've got gate on pin 1, drain on pin 2, and source on pin 3. Okay. Right, yeah. Okay. So snips, tin snips. So I'm going to modify the pins a little bit on here, and I'm going to go. Right, so I'm going to cut the gate a little bit. The reason I'm doing that is that I want to put one resistor from the gate to ground, so it makes sure it's always turned off when it's meant to be turned off. Otherwise, it would be left potentially floating. Probably can't see much now anyway. Right, so wrap it around. I'm obviously going to solder it as well, but just so it makes my life a little bit easier whilst I am soldering it, so it doesn't flip around a bit. Right, so put that there. Attach some solder on. And snip that leg of this resistor as well. Right, I'm going to splay out that leg. So never get used to working on the camera. So I'm splayed out that leg. That's going to come down and touch to ground. So that is your source. Okay, and the middle pin is going to need to connect to the power resistor. So you should also note, be very careful of the tabs on, well, any transistor that's open tab. These are TO220 case style, so the tabs are also connected to one of the legs, and in this case it's a drain that tab is connected to, so that would end up connecting to the resistor, which we don't want to come into contact with ground, otherwise it will always be on. So I'm going to mark this a little bit, and then I'm going to run a strip of tape down there. About even, I hope so. Another piece as well. Now, the particular MOSFETs that I'm using, as I said, they are logic level turn on. They're also, I think, 20 or 30 amps. Just have a look at the data sheet just to confirm that 30 amps. So loads of capacity, because we're only going to be pumping in less than 1 amp. So we're not too worried about any heat dissipation from those MOSFETs, because they're barely working. So middle leg of the MOSFET onto the other end of that power resistor. Should, I suppose, zoom down a little bit for you guys so you can see a bit more. Right, there we go. Hopefully it focuses. I appreciate the copper is quite shiny. So, middle leg of the MOSFET to the power resistor on that side. I've bent up the legs on the power resistors so I can connect things to them. So one thing that I need to connect to is the Arduino on the analog inputs. So that's going to be on the battery terminal bit there. So I need that. Next is that resistor that we put on the first leg, pin 1 of the MOSFET. We're going to need to tie that down to the ground. So I'm going to do that now. A little bit shy on space down here, but we'll get there. Right, so that's connected. We need to put the third leg, the source leg, down onto ground. So that enables the MOSFET to switch to ground. Thus, basically the MOSFET acts as a switch. So as soon as you power up the MOSFET, it will close its contacts and go to ground, which thereby completes the circuit on the battery, meaning that that resistor is now its load on the battery and is loading by 4 ohms ish, which will be our 800 milliamps ish. But obviously as the battery voltage goes down, so will the sorry, I'm moving this around, so will the current. So next, what do we need to do? Well, I'm also going to put a LED in, so the Arduino will control the cutoff voltage of the battery. So I'll set it to like 3 volts cutoff, and it will then turn off. So if we have a LED on here as well, we can then tell when the battery is on load and working, and when it's finished working. These are mini LEDs, but they do the job. So I need right. Well, I've only got 1K resistors here, so that's going to have to do. Not an ideal resistor value for that, really, but still, it'll do. So, right. Engage brain a little while. I'll just snip the leg down on this one. Oh, I'm off the camera again. Useless, aren't I? Useless. Right, snip down the leg on there. I'd normally put like a 470 ohm resistor in for an LED on 5 volts or 5ish volts to drive them, but it means going to the other side of the workshop, and I'm just not going to bother, so I've used 1K. This is where a pair of helping hands comes in, quite useful. Trying to stick 2 components together. Okay, so that's on there. Right, so I now want to get another 1K, and I want to use this one as the connection to the gate, and this will then go off to the Arduino, and the gate controls the source and the, stick that on there, the source and drain, thus completing the circuit. So I bet this is going to be a really boring video. the other side of that LED to the leg of the power resistor. And then we will wrap that around there a little bit. So that's that part of it done. Very, very simple. So all now we need to do is apply 5 volts to that leg of the joint of the resistors. I'll bring this up a little bit. There we go, and we'll talk it through, shall we? Oh God, my camera work. There you go. Look, can't figure out what I'm doing, where I'm pointing. Right, okay. When the camera comes into focus, right. So that's what we got. We got an LED. We've got a resistor in there to limit the current to the LED. The LED tip leg goes down onto the bottom of this power resistor. That power resistor then connects into the drain of the MOSFET. The other side of the LED goes via that current limiting resistor, and that will go off to the Arduino on that pin, which we'll wire up in a minute. So also 1K resistor down to the gate, and then the 100K from the gate down to ground to make sure that it doesn't float and bounce up and down and do strange things. So all we have to do is 5 volts on, oh God, camera work again, appalling. I need to zoom out a bit now, don't I? Oh, wrong way, always the wrong way first. So all we have to do is apply 5 volts to this, and that will engage the MOSFET, and if there's a battery in the bay, it will then power up and drain that battery down. So the intelligent part is going to be having that Arduino on the board, and that will control how far down the battery drains. So I'm going to go and wire up some more. I'll put some screw holes in for the Arduino, which will just about fit in there. I think I might have to stand it up a little bit. Okay, so we've now wired the rest of the MOSFETs, resistors, LEDs for a 4-bay capacity checker. I've also drilled a few holes in the board and mounted the Arduino with some pillars off the board, 4 mounting points. So that's that in there. Now, what we've got to do is we've got to link up the 4 gates and the 4 analog inputs to the Arduino. So I've got some of these pre-crimped ribbon cables, so I'm going to rip off, am I going to rip off 4 of these? No, I'm not going to do that because that'd be wrong. Right. I need the other type, the type that's in this bag. Right, these ones, that's the ones I want. So they've got pins on the end, so they plug straight into the Arduino board. Okay, so we'll start with yellow, orange and red. And with a bit of luck, these will actually plug in to the big wires on the resistor, on the power resistors, and they do, so that's lovely. So we connect those up, makes it nice and simple. The cables are massively long because the board's only there, so it's going to be a bit messy looking maybe. If we go for it, we'll see if we can bend that in a little bit. Right, there we go. And we've got the analog inputs on the Arduino down here, and they start at A0, so that'll be yellow, followed by A1, A2 and A3, and they're the corresponding battery banks. So that's those plugged in. I might be able to make it look a bit neater, maybe, I don't know. figure a way of tucking the cables down somewhere. I think they probably will tuck. Right. In the meantime then, the next thing we need to do is wire up the gates for this. So, the way the code works is that we're using the outputs down here of the Arduino, and we're going to start at output 2 on here, mainly because output 0 down here is the received data, RS-232, and output 1 is the transmitted RS-232 data. So we're going to leave those separate and not bother with those. As there's loads of pins and I/O lines on this board, we're not too shy about that. So I now need to wire up the next bank, and I need to have I'm going to need to cut some of these now. So we go. Should we use the same colours again? Make it simple. So yellow to brown on these. There we go. So they can plug in again. So from pin 2, looking at the code quickly, 3, 4 and 5 is the first bank of 4 cells to be tested. So that is from there. So if I plug them all in at the same time, from there to there. So what we're probably going to do here is bend those under. They can tuck underneath the board and come back up on the other side, and then we will wire them in. So first is yellow. Cut those about there. Put those to one side. I might use them for something one day maybe. Right. My super duper strippers. I might have to adjust these a little bit. Oh no, it's okay. I thought it wasn't going to strip the cable because it's quite thin compared to what I have been doing with these recently. Again, massive plug for these CK wire strippers. If you haven't got a pair, go get yourself a pair. They will change your life. Lovely, right. So before I pass them under the board, I'll just twist the ends so that they're nicely gathered together, the strands of copper in the cable, and then I will pre-tin them just to make my life a little easier when we get to the other side. Okay, so we tuck it under the board. I'll get frustrated in trying to figure out where all of the cables are gone. I'll probably end up burning myself. Oh yes, and you see I'm getting frustrated already. I've lost a cable somewhere. The brown one's disappeared. Oh, there she comes. Right, okay, so I need to cut down these a little bit. I left the legs long last time in case I needed to use them for anything. So we need to go yellow, orange, brown. So gets a bit fiddly. So yellow's on. Go for orange. Not sure if you can see me doing what I'm doing, but trust me, it's fiddly. Obviously you don't have to try and compact it as much as what I've done, but I'll unplug those ones for a minute. I just want to try and make it neat and compact. Bijou, they say. Need a bit of solder. Lovely. Last one is red, which is this little guy here. Doing some tweezers right about now. Never mind. What fingernails are for, I suppose. Getting burnt. Okay. So that's our 4 lines in. Plug these back in. Put that sound at the door. Right. So that's our 4-way tester essentially. Now we've got to do some code. So let's get the code plugged in. Okay, so we got code. It's very simple code. I've put all the code in for like doing a 16-way. I haven't made the 16-way up yet fully, but it's a case of copy and paste, like I said earlier on, with electronic parts. So anyway, I'll put the code somewhere that you guys can download it. But the main part of the code consists of this little bit here. Basically is checking and calculating the current and then sending it out through the RS-232. So without further ado, I'm going to hit upload. It's going to tell me it's failed miserably because I've connected it to the wrong serial port probably. Oh no, we're done. Right, so she's down here. I forgot to mention also when I was doing the soldering, and I didn't film it, but you need to make sure there's a common ground with the MOSFETs, the Arduino, and anything you're doing basically. So I've put a ground pin up here, that one there, and that runs down to the copper boarding and soldered down. Anyway, we need a battery, so I'm going to grab a battery. We've got a, what have we got? So LG something or other, half covered. That one will do. Charged it a while ago. So with a bit of luck, if the battery's got enough voltage, it isn't a dud, that LED is going to come on. There you go, LED's come on. So it's now testing that cell. So that resistor will start to get warm in a minute. But up here, if we look at, so if we open up a terminal window, it's gone to my other screen. Right. So there we go. Right. So we can now see that's the results that you get. So we can see battery 0, which is the one we just plugged in. It's at 3.52 volts. The current draw on it is 879 milliamps, and that calculated capacity at the moment is 0.0059 amp hours. But bear in mind, it's only been on 35 seconds. So you then leave it to carry on discharging. When that LED goes out for say 10 minutes or so, you know that that battery is now depleted and is sitting at 3 volts, which means you can then come back to your software and you can see how much capacity it actually has. One note I would make about the Arduino, so you don't upset yourself, is that anytime you open up or do anything to do with the COM ports, so if you open up this serial window again, it will reset the Arduino. If you unplug it, obviously you'll lose power and you'll lose your results, so be very careful what you're doing about that. In a later video, when my screen arrives, we'll put a LCD screen on here and we'll make it plot out the results on the screen, so it makes it a standalone unit instead of outputting them to the PC. Right, second thing to note, this is quite important. I've made this software adjustable. So towards the top somewhere we have some factors. Right, So one factor is the voltage input to the Arduino board. At the moment it's running off my computer USB, and the computer USB I've multimetered and it comes out at 4.82 volts. It's important you can factor this into your calculations for current, because it's all derived from a voltage and fixed numbers, and the 5 volt of a USB is not always 5 volts, so remember to do that. Also, your resistor value, you must put a resistor value in there. I've used 4 ohms. You might want to use 8 ohms or something, a lower current draw. That must be put in to whatever it is your chosen resistor value for the power resistor. You can also see here cutoff. This is the voltage that the Arduino will stop pulling current from the battery. So when it hits 3 volts, it'll stop. And then what I've also done, which we can see on the startup window, is it tells you what it is basically. There's a voltage factor in there, and that's calculated down on the results. So current is voltage divided by the resistance, capacity is current, time in milliseconds, in seconds in an hour. Calculating your current. What else do we need to say? Oh, that's the cut-off voltage there. So if it hits the 3 volts, which we marked earlier on, it'll cut it off. The current and capacity are done in floats, so that's why I put 4 in, so that when it prints it to the serial port, it'll print you the 4 digits after the decimal place, so you get the full whack. Otherwise, that's about it. It runs off a timer, so every second it runs through and makes sure the battery isn't dipping too low on voltage, and takes the next reading. Otherwise, really simple, and that's it. Really, I can't think of anything else that might trip you up in doing it. I think basically now is, if you've managed to watch the whole length of this video, that's going to be about, I don't know, 40 minutes long. You've either got incredibly bored or you're really interested in making one. So well done. Go forth, build, enjoy. Comments, questions, stick it down there on the tube, and I'll see if I can help. But otherwise, yeah, if you're doing the 16-way one, then just put 16 test stations like this one, and just copy them all and link them up. Simples. Okay, happy days, have fun, go build, be creative, get on with it. Cheers.